It takes many billions of years to create a galaxy like the Milky Way, a galaxy with 100 billion stars, many of which are billions of years old. However, the James Webb Space Telescope, JWST, has identified 6 galaxies that existed only 500 million years after the Big Bang. Imagine seeing a galaxy that's only 600 million years old, a time when the universe was still in its infancy, long before the Milky Way even existed. Thanks to the power of the JWST, we can now peer into the distant past, witnessing the birth of galaxies with unparalleled detail. Meet the Firefly Sparkle galaxy, a cosmic time capsule that's changing everything we know about the early universe. This discovery is especially significant because, despite the galaxy's extreme distance, over 13 billion light-years away, the JWST was able to resolve individual star clusters and key structures within the galaxy. This is a rare glimpse into the early universe, a time when galaxies were in their infancy. The Firefly Sparkle galaxy provides a look at one of these first-generation systems, offering astronomers a detailed view of how galaxies like the Milky Way might have formed in the early universe. The Firefly Sparkle galaxy is not just a distant on the cosmic map. It's a dynamic, evolving system. Its study offers insights into the mechanisms that shape galaxies over billions of years. This marks a critical moment in our understanding of the universe's development, as we can now observe the processes that led to the formation of the galaxies we see today. One key theme of this discovery is galactic cannibalism and galaxy formation. Galactic cannibalism refers to the process by which smaller galaxies merge into larger ones over billions of years. Galaxies grow not only by forming stars but also by absorbing smaller galaxies in their vicinity. Just as a larger corporation might absorb smaller companies to expand its reach, larger galaxies pull in smaller ones, contributing their mass, stars, and gas. This process significantly accelerates the growth of a galaxy, triggering bursts of star formation and shaping its structure over time. The Firefly Sparkle galaxy is a perfect example of galactic cannibalism in action. As it evolves, it is currently merging with 2 smaller companion galaxies. This is not an isolated event. Galaxies are constantly on the move, and smaller ones often get caught in the gravitational pull of larger galaxies. These mergers lead to the creation of more massive and complex systems over time. In the case of the Milky Way, we see evidence of galactic cannibalism as well. Our galaxy has grown significantly over billions of years by absorbing smaller galaxies. This process continues even today, with the Milky Way currently in the process of merging with nearby galaxies, including the Sagittarius dwarf galaxy. The discovery of Firefly Sparkle, with its ongoing mergers, helps reinforce the theory that galaxies like the Milky Way grew not just through star formation but through massive cosmic mergers. To capture the Firefly Sparkle galaxy in such detail, astronomers relied on gravitational lensing, a phenomenon where light from a distant object is bent and magnified by the gravitational pull of a massive object in between, like a galaxy cluster. This acts as a cosmic magnifying glass, allowing us to see distant galaxies that would otherwise be too faint or far away to study in detail. In this case, a massive galaxy cluster called MAX J11423, located 6.6 billion light-years away, magnified the light from the Firefly Sparkle galaxy. This lensing effect made the galaxy appear brighter and larger than it would otherwise have been, enabling JWST to capture intricate details of its structure. The advanced infrared technology of the JWST allowed astronomers to observe this distant galaxy, despite it being billions of light-years away and obscured by cosmic dust. The combination of gravitational lensing and JWST's powerful infrared capabilities gave us a level of clarity and detail that would have been impossible with previous telescopes. Without this magnifying effect, Firefly Sparkle would appear as a mere smudge in the vastness of space, but through gravitational lensing, astronomers were able to observe individual star clusters and gas clouds, revealing the galaxy's global structure, a key feature that suggests the galaxy is still in the process of formation. The Firefly Sparkle galaxy offers an invaluable opportunity to study the building blocks of a galaxy, star clusters. By observing the star clusters within the galaxy, astronomers can understand the stages of star formation and learn how galaxies like the Milky Way were built over time. Firefly Sparkle's Babel distribution of star clusters, with 2 distinct areas of concentrated clusters, suggests that star formation in this galaxy is occurring in bursts. Some clusters are very young, while others are much older. The fact that this galaxy is still in the process of forming means it is experiencing bursts of star formation, a key feature of galaxies in their early stages. These bursts are often triggered by gravitational interactions and help drive the growth of galaxies by creating new stars and gas clouds. The clusters that are young and blue are likely newborn stars that have just started forming, while the redder clusters are older and may represent some of the earliest stars in the galaxy. This pattern of sequential star formation suggests that rather than forming all at once, galaxies like Firefly Sparkle develop over time through multiple phases of intense star creation. This pattern of star formation also provides insights into how the Milky Way and other galaxies formed. Like Firefly Sparkle, the Milky Way likely started with more rapid star formation in its early stages before slowing down over time. The study of galaxies like Firefly Sparkle helps astronomers understand how massive galaxies grow and evolve, giving us a clearer picture of how galaxies like the Milky Way came to be. The Firefly Sparkle galaxy provides a fascinating comparison to the early Milky Way. Both galaxies are in similar stages of development, with multiple star clusters at varying ages. This suggests that the early Milky Way was likely very similar to the Firefly Sparkle galaxy, small, chaotic, and filled with bursts of star formation. Just as Firefly Sparkle is growing by merging with smaller galaxies, the Milky Way also grew by merging with other galaxies in its early history. The study of Firefly Sparkle is a unique opportunity to test our hypothesis about the early Milky Way. By comparing the two galaxies, we can gain a better understanding of how the Milky Way formed through mergers and rapid star formation. This discovery provides a cosmic snapshot of the early stages of our galaxy's formation, offering clues about the processes that led to the Milky Way becoming the massive spiral galaxy we see today. As we now transition into a deeper exploration of the Firefly Sparkle galaxy, we return to the concept of galactic cannibalism. Galactic cannibalism is not only a process that shapes the structure and size of galaxies like the Milky Way but also dictates their evolutionary paths. Just like the merging of small companies into one large corporation, galaxies undergo a similar process of absorption and transformation. However, the stakes are much higher in the cosmos. Galactic cannibalism allows for a faster pace of galactic evolution. Instead of waiting for incremental star formation to build a galaxy, mergers introduce new stars, new materials, and an entirely new structure. The Firefly Sparkle galaxy, for example, is currently in the process of merging with two smaller galaxies. This interaction creates a dynamic, evolving system that accelerates the growth of the larger galaxy. The burst of star formation within the galaxy is a direct result of these mergers, demonstrating how small galaxies can contribute their mass and energy to the larger structure. What's fascinating here is that galactic cannibalism challenges some older models of galaxy formation. Traditionally, many believed that galaxies grew in a steady, smooth fashion without much dramatic change. However, the Firefly Sparkle galaxy reveals a much more chaotic process involving interactions, collisions, and merging galaxies. This discovery affirms the notion that galaxies like the Milky Way didn't just grow gradually, they grew through violent cosmic mergers. This reinforces the idea that galaxies like the Milky Way have a tumultuous past, constantly absorbing smaller systems to fuel their development. One of the best-known examples of this process is the Sagittarius dwarf galaxy, which is currently being consumed by the Milky Way. This smaller galaxy, much like the ones the Firefly Sparkle galaxy is merging with, is contributing to the growth of our own galaxy. In the business world, mergers and acquisitions, M&As, are central to the growth of large companies. Large corporations often acquire smaller ones to expand their resources, reach, and influence. The same is true in the cosmos. Just as M&As allow businesses to dominate their industries, galactic mergers create the massive, complex systems we see today, like the Milky Way. The Firefly Sparkle galaxy gives us a living, breathing example of this cosmic business transaction, revealing how mergers between small systems lead to the birth of something much larger. Real-world data supports the idea that galaxies often undergo these processes earlier in their life cycle. Observations from JWST have shown that the universe was far more active and chaotic in its early stages. Faster star formation, high-density gas clouds, and frequent interactions between small galaxies help trigger this rapid growth. One of the most crucial, though invisible, components involved in galaxy formation is dark matter. While we cannot see dark matter directly, its influence is clear in how galaxies form and grow. Dark matter is thought to exist in massive halos around galaxies, providing the gravitational pull needed to keep these galaxies intact as they absorb smaller galaxies. Without dark matter, galaxies would not be able to maintain their shape and size through these mergers. It essentially acts like the foundation of a building, invisible but essential for keeping everything together. In the case of the Firefly Sparkle galaxy, dark matter likely played a vital role in the galaxy's early formation. As smaller galaxies collide and merge, dark matter helps to stabilize the galaxy's structure, preventing it from collapsing or being destroyed in the process. By studying the distribution of dark matter in galaxies like Firefly Sparkle, astronomers are starting to piece together the role it plays in the cosmic puzzle of galaxy evolution. Think of dark matter like scaffolding around a construction site. While it's not seen directly, it's holding up the entire structure. Without it, everything would collapse. The discovery of two companion galaxies near the Firefly Sparkle galaxy is crucial for understanding its future. As we've seen with galaxies like the Milky Way, merging galaxies are not a one-time event. The two companions of Firefly Sparkle are destined to collide with it in the future, a process that will only increase its size and mass. This reinforces the idea that galactic cannibalism is an ongoing process. Just as the Milky Way is still absorbing smaller galaxies, Firefly Sparkle's future evolution is likely to mirror this, growing larger and eventually merging with these two companions. But this process is not limited to just these two galaxies. Throughout the universe, galaxies are constantly merging, colliding, and growing. These mergers lead to the creation of even larger systems, contributing to the cosmic web of galaxy formation that we observe today. The Firefly Sparkle galaxy is just one example of this grand cosmic dance, and its future holds even more exciting insights for scientists studying galaxy evolution. The discovery of the Firefly Sparkle galaxy and its role in galactic evolution is a breakthrough in understanding how galaxies grow. We've seen how galactic cannibalism accelerates galaxy formation, contributing mass and energy to the larger systems that result. Through the lens of gravitational lensing and the power of the JWST, we've gained an unprecedented view of this galaxy's development, offering a glimpse into the tumultuous early universe. This discovery not only gives us insight into the formation of galaxies like the Milky Way but also confirms that galactic evolution is anything but smooth. The process of merging galaxies and absorbing smaller systems is a chaotic and fascinating journey, one that has shaped our cosmic neighborhood and will continue to do so for billions of years to come. The Firefly Sparkle galaxy offers a snapshot of this ongoing process, revealing the violent, energetic growth that leads to the formation of massive, complex galaxies. In the end, galactic cannibalism is a central force in the evolution of galaxies. By studying galaxies like Firefly Sparkle, we can better understand how systems like the Milky Way grew through mergers, star formation bursts, and the gravitational interactions that continue to shape their development. This discovery not only teaches us about the past but also offers predictions for the future of galaxies, including our own. So, what's next for Firefly Sparkle and its companions? They will continue to merge and evolve, growing larger and more complex over time. This is the path of all galaxies, including our own, which will likely continue to absorb smaller galaxies for billions of years to come. The Firefly Sparkle galaxy shows us that the universe is always evolving, with constant mergers and transformations as it continues to explore the wonders of the cosmos. The Firefly Sparkle galaxy's discovery also challenges our understanding of the early universe. It provides evidence that galaxy formation and evolution may not have been as orderly and gradual as once believed. Rather, the process of galaxy growth may have been driven by chaotic interactions, such as mergers and rapid star formation, which occurred in the infancy of the cosmos. This newfound understanding could reshape models of cosmic evolution, suggesting that galaxies formed and matured much more dynamically than previously assumed. In addition, the Firefly Sparkle galaxy's ongoing interactions with smaller galaxies highlight the interconnectedness of galaxies across the cosmos. These mergers create intricate networks of stars, gas, and dark matter, further enhancing the understanding of how larger cosmic structures develop. As galaxies collide and merge, they influence one another's development, creating a ripple effect that ultimately leads to the formation of galactic clusters, which are themselves key features of the universe's large-scale structure. The role of dark matter in these early galaxy mergers cannot be overstated. As invisible matter that exerts gravitational forces, dark matter provides the necessary foundation to keep galaxies intact during these violent mergers. It acts as the glue that holds galaxies together, stabilizing their structure and preventing them from disintegrating as smaller galaxies are absorbed. While the exact nature of dark matter remains elusive, its influence on the evolution of galaxies like Firefly Sparkle is critical to understanding the larger picture of cosmic growth and evolution. Looking forward, the study of galaxies like the Firefly Sparkle galaxy provides a window into the universe's future. As galaxies continue to merge and grow, the cosmic landscape will become more complex, with new systems emerging and evolving over billions of years. For scientists, observing the Firefly Sparkle galaxy today offers the opportunity to study the forces that have shaped, and will continue to shape, the galaxies of tomorrow, including our very own Milky Way.